This is another section 3.2. This is modeling with quadratic. So basically we're going to take quadratics and put them in word problems and applications. Now this is what this section is about. So we have a ball is thrown upward at 96 feet per second. So that's the unit of velocity from a height of 8 feet. The height of the ball can be modeled by this equation, where t is the number of seconds after the ball is thrown. So s is the height. Is the height of the ball. So in an ordered pair, you're going to have seconds and height. How long after the ball is thrown is the height? 148, sorry about that, 148 feet. So S is equal to 148 when. So we're going to plug that into the equation. And it's a quadratic, so to solve it, we need to have it equal to 0. So let's move the 148. So let's go to the calculator. Same thing we did in the last section. We're going to use the polynomial tools and just go ahead, since we use complex roots, let's use complex roots. So let's put that in. Again, I prefer X's. You can leave it as a T. You just have to do comma T at the end instead of comma X. So 5/2 and 7/2. So 2.5 and 3.5. And I don't remember if they want fractions or decimals on this. So read where you put the answer. See if the word fraction is in there, you're going to use a fraction. So let me show you what's happening. We start at a height at 8 feet. The ball is thrown upwards. The ball is going to go up and then come down. This is not to scale. So we want to know when it reaches a height of 148 feet. So it reaches the height on the way up at, that was 2.5 seconds. And on the way back down at 3.5 seconds. So that's why we have two answers. Now, if one of those was negative, you can't have negative time. Okay, so you wouldn't use it, but both of these are positive. So on the way up and on the way down, it hits a height of 148 feet. Let's look at our next one. The profit for a product is given by this function here, where X is the number of units produced and sold. So our P of X is going to be our profit. So in an ordered pair, you have units and profit. How many units give break even? That is, give 0 profit for this product. So we're going to let this equal 0. And as you're writing these notes, you make sure you make notes that you're using C poly roots, possibly how to get to it, anything you need to add for future reference. Let's flip back over to the calculator. So we're going to do polyroots. Okay. Comma X at the end, don't forget that. And I see what I did wrong. It's like those numbers don't look right. It's 1870. All right, so 50 and 60. And if you didn't see what I did, I saw that I had an error. I just arrowed up until I got where I wanted and I hit enter and it's a copy and paste. So from there, I edited it. I actually accidentally had a 9 in there. I just deleted it. And then you hit enter again. So you don't have to retype the whole thing, but you can retype the whole thing if you prefer. So that's going to be at 50 and 60. So I'm just going to sketch. I can show you what this is going to look like. All right, this one's going to open down. So 50 units and 60 units. And a profit, so it's up here you're making a profit above the x-axis. Below the x-axis, you have a loss. So you have a profit when the curve is above the x-axis, and that is between 50 and 60 units. So maybe under 50 units, you can't purchase enough materials to get a discount in bulk, so you're not making any profit. But if you produce more than 60 units, maybe you can't afford the overtime that it would cost to produce 60 units, and therefore you're not making a profit. So you would be making a profit when you produce 50 or between 50 and 60 units. It doesn't say whether it's a day, a month, a year, depending on what the units are. All right, this one's going to make you use your brain a little bit. The amount of particular pollutant P from a power plant and the air above the plant depends on the wind speed S, among other things. Okay, so the wind speed would be your X, and that determines how much pollutant is in the air. So that would be your Y. All right, so the relationship between P and S, so which one is P? S is our wind speed, is approximated by this function here, where S is in miles per hour. Miles per hour. Find the values or values of S that will make P equal to 0. So plug 0 in. Because there's a square on it, that means see polyroots. Numerical solve is ones that don't have an exponent on it. Right? And I'm going to change mine to an X if you leave it as an S for comma S. So negative 20 and positive 20. So if P is equal to 0, what does that mean? P is our what? P is our pollutant. So if P is equal to 0, that means there's no pollutant in the air. And then which one makes context? Which answer makes sense? We have two answers. We have S is negative 20, S is positive 20. This is our wind speed in miles per hour. So which one makes sense? The positive one makes sense because you can't really have a negative wind speed. Okay, whether it's going forwards, backwards, north, south, east, west, there's still some type of speed, and speed is not negative. So this is an example where the negative answer, they call it an extraneous answer, doesn't apply. Like if we were to have negative time, we wouldn't use that. That would be an extraneous answer. You get that sometimes with quadratics and you're solving for a time. All right, let's see. We have drug sensitivity here. So this question came out in textbook. It's a little weird. Anyway, the sensitivity as to a drug is related to the dosage size, X. So we have dosage and sensitivity. So that's going to be X and S. X is the dosage size in milliliters. What dosage or dosages would give a zero sensitivity? So S is equal to 0. So we're going to plug that in. Let's go over to the calculator. We have something with a square on it, so we're going to use C poly roots. Comma X at the end. Don't forget your square. So 0 and 700. So it's a drug. So the dosage, we have 0 milliliters and 700 milliliters. So the first one's kind of obvious. Why would you have zero sensitivity with 0 milliliters? That's the dosage of the drug because there's no drug in the system. All right, and this one's a little bit different. Why would a dosage of 700 milliliters give a sensitivity to the drug of 0? Because they had an overdose and they passed away as a result. Again, this question came out of the textbook. Let's look at our last one. The UN data from 1975 and projections to 2050, the number of millions of people aged 15 to 59 in a country can be modeled by this equation right here, where X is equal to the number of years after 1970 and Y equal to the millions of people in this labor pool. Use technology to find when the population is expected to be equal to 737 and 1 million. So we're going to let 737.1 be equal to our equation. Now again, we have a square in here, so we can use C polyroots, which means it has to be equal to 0. Everything to one side. Over to the calculator. We're going to see polyroots again. My X at the end, no equal sign with C polyroots. All right, so 29.8, that's going to round to 30, and then 55. Again, it's not an ordered pair. Those are two solutions. So 29.8 and 35, or 55, I'm sorry. At 29.8 is going to round up to 30. Okay. But X is the number of years after 1970. So we're going to add 30. So the year 2000. Add 55 here. So this population will be 737 and 1 million in the years 2000 and in the year 2025. So the population is going to increase and then start decreasing. So 737.1 million in the year 2000 and in the year 2025. So that's why you have two answers, because population is going to peak and then it's going to start decreasing. And that is it for section 3.2.